It says, for t greater than 0, if we let x equal t squared and y equal cosine of t squared, it says then the derivative of y with respect to x equals what? Well, remember the derivative of y with respect to x when we have a parametric curve. All we have to do is take the derivative of y with respect to t, and then we simply divide that by the derivative of x with respect to t. So nothing too hard here. So if we take the derivative of the y part with respect to t, okay, so I'm looking at the first part, well, the derivative of the outside will be negative sign. We leave the inside alone, t squared, but then we have to multiply by the derivative of the inside, so we'll have to multiply by 2t. Well, the derivative of the denominator, t squared, will also just be 2t. Those will simply cancel out, and to me it looks like we're left with negative sign t squared. Okay, that will be your answer. So nothing too bad there at all. Just remembering that basic formula and your derivatives just a little bit. Question number 4 says the function, so it says the function f of x equals 4x to the third minus 8x squared plus 1 on the interval negative 1 to 1 has an absolute minimum. So it has an absolute minimum at what x coordinate is the question. Okay, well, in this case, if you remember the closed interval method, basically all you do is you find critical points for this function that fall within this interval. You evaluate this function at the critical points that fall in this interval as well as the endpoints themselves, and the smallest value simply is the absolute minimum. So, okay, so the derivative of 4x to the third minus 8x squared will get 12x squared minus 16x, it looks like to me. Let's see, so how can we factor this? We can pull a 4x out of both of these parts. I would need a 3x for the first part, and it looks like I would need a minus 4 for the second part if I were to distribute. So we want to find critical values, we want to find where the derivative is either equal to 0 or undefined, and those values have to be in the domain. This is a polynomial. It's defined everywhere. It's also continuous everywhere, but in this case, it's not going to be undefined anywhere, so all we have to do is set it equal to 0, and that means simply that 4x equals 0, 3x minus 4 equals 0. Solve each piece, we'll get x equals 0, add 4, and divide by 3. So we get our solutions to be x equals 0 and x equals 4/3. Notice 4/3 doesn't fall in the interval from negative 1 to 1, so we don't use that critical number at all. If our interval had been from negative 2 to 1, we would have included that value. So now I just have to evaluate the function at this one critical point along with the endpoints. And again, the biggest values would be the absolute max. The smallest value is going to be the absolute minimum. And again, this only works, I think that's why I was thinking about continuous. You can only use this closed interval method if your function is continuous over the closed interval, which it is. So we have to evaluate the function at negative 1, we have to evaluate it at positive 1, and then we're going to have to evaluate it at 0, the one critical point that we kept. So if I plug in 0, we're simply going to get 0 minus 0 plus 1, or we'll just be left with positive 1 for f of 0, so that part's easy to compute. If I plug in positive 1, we'll get 4 times 1 cubed, which will be 4, minus 8 times 1 squared, plus 1. Well, 4 minus 8 is negative 4 plus 1 is negative 3. If we plug in negative 1, we'll get 4 times negative 1 cubed, which will give us negative 1. Minus 8 times, negative 1 squared is still positive 1, plus 1. So it looks like we get negative 4 minus 8, which is negative 12, plus 1 is negative 11. So to me, I would say there's an absolute minimum at the x-coordinate of negative 1. Okay, so again, I hope these questions help. If you have questions or comments, feel free to post them, and hopefully somebody can help you out. Otherwise,